Hello everyone, good morning. So my assigned number is group 3 and the given formula is C6H12O2. So based on the given formula, I have first started taking the DU, the degree of unsaturation. The formula is 2 carbons plus 2 plus nitrogens minus hydrogens or minus halogens. So there are no hydrogens, sorry, there are no nitrogens and halogens. So the formula I have applied and the answer is 1. So it means there is a 1 ring or a 1 pi bond. And there is also O2 in the formula indicating that there will be a double bond O. Could be. So, second, when it comes to the IR spectrum, there is a stretch at 1700 which highly indicates the C double bond O, which we have discussed in the DU as well. And there is a stretch at 3000 which is like sp3 CH bonds, and from 1500 to 1000 there are multiple stretches which indicates the C single bond O, and there is also no OH stretch. That should be some around 3200 to 3600, which indicates that this is not a carboxylic acid. This could be a biggest indicator. And when it comes to the 13C, we have there is a chemical shift at 170 and at 60, 58, 56, and at 42, 46, and also between 25 to, sorry, 30 to 20. So at 170, that could be a C double bond O, which could be because of the strong deshielding of oxygen. And at 52, that could be like OCH3 bond methoxy, which could be which is reduced because of the deshielding by electronegativity of oxygen. And at 41, it could be like CH2 at C double bond O. And at 26, it could be a branching. And at 22, it could be the methyl group. And at 1H, there are totally 4 indicators. So one, I'm sorry. The first indication is at 3.7 to 3.8, which is the integration of 3H, and it's a singlet. So that indicates a CH3, OCH3, which is the methoxy of methyl esters. And the second one is at 2H, which is at 2.2 to 2.4, the chemical shift, and the integration is 2H, and it's doublet 2. So that could be the CH2. And at 2.1 to 2.0, there is a 1H integration, and there are multiple. So that could be the methane, the CH group, which because it is surrounded by the CH3 and CH3. So 3 plus 6 plus 1. So it could be the septane, so multiple. And at 0.96, there are 6H integration and the chemical shift at 0.96. So that is doublet. So that could be like 2 equivalent CH3 groups that are attached to the CH. So based on these, so the proposed structure is CH3O, C double bond O, CH2, CH3, and CH3. So there are 2 CH3s, 1 CH, and 1 CH2, and 1 carbon attached to oxygens. So the proposed structure is like methyl 3 methyl butanoate. This is the skeletal structure, and this is the condensed structure. So finally, I think so this is my explanation. So C6H12O2 gives like the degree of unsaturation is 1, and there is a strong H at 1700, which is the carbonyl CO band, and at 1250, and with no OH, which can eliminate the carboxylic acid groups, and which indicates it's an ester. And these are the peaks which helps us understand the CH3, CH2, and CH stretches. So, yeah, this is it. Thank you.